Okay, well, it's it's good to be back. It's been an adventurous week and weekend, so I'm around, I guess, at least for a little while. I want to go through a couple of last things since this is probably our last full week together. I want to go over the two uh, basically solver problems because one of them you will be using for that last section of Betty's Bats. So I'm going to share a screen with you. And the first one I want to go over, hopefully you had success with the previous one. So with this one, I just want to state that this one's a little bit more involved. You remember the previous example, it was a little, 1 by 2 matrix. You had a choice of making SPA 1, SPA 2, and we were trying to maximize something because, as I mentioned, as far as the optimization is concerned, we're always trying to maximize something or minimize something. Well, in this example, it's a little bit more involved, a little bit more to it. What we're looking at is an outcome where we're trying to minimize something. And what we're trying to do is minimize cost. So the storyline, again, not that that's a big deal, but in this case, whatever the storyline, this is a company that makes, and again, it doesn't matter what the actual piece is, but they make an electronic component. And let's just call it, they make a Model 1, a Model 2, and a Model 3. Now, they have an ability to make a certain amount, certain capacity, like every firm has some maximum capacity somewhere. So they make a Model 1, a Model 2, and a Model 3. And we start to see that there are costs associated with making these devices. So it costs this company $50 to make each Model 1. It costs this company $83 to make each Model 2. And it costs this company $130 to make each Model 3. Now, they also have the capacity to go out and buy, presumably from a competitor, but at a wholesale price, a Model 1, Model 2, and Model 3. And the cost to buy is $61 for a Model 1, $97 for a Model 2, and and $145 for a Model 3. So here's the thing. This is their order. They receive an order that says, we got to have 3,000 Model 1s, 2,000 Model 2s, and 900 Model 3s. Okay. Well, again, it would be a simple decision if there weren't constraints, but there are constraints or limiting factors. And what we have for each of these things, we have consumables, which include wiring time, the time it takes to wire one of these devices, a Model 1, a Model 2, a Model 3. And we have a total of 10,000 hours available. There is harnessing time, and we have a total of 5,000 hours available. And we look further and we see that, okay, to make each Model 1 takes 2 hours of wiring time, 1 hour of harnessing time. To make each Model 2 takes an hour and a half wiring time, 2 hours of harnessing time. To make each Model 3, it takes 3 hours of wiring time and 1 hour of harnessing time. And again, we're trying to meet this order, but minimize costs. So we don't have the capacity to make 100% of this order. Obviously, it would be easier if we could just make it all and meet the order, and it is what it is. But we're going to have to go to the outside and buy some at wholesale to complete this order, because again, it's an all or nothing proposition, 3,000, 2,900. But then the question ensues, in attempting to minimize costs and therefore maximize profitability, of course, but to minimize costs, which should we make and how many? And which should we buy, if any, and how many? Well, again, using Solver, we set this thing up, and I've given you a little cheat sheet legend here, assign an outcome cell or a result cell, whatever, and we've done that here. That's E11. Assign the variable cells. Well, this is the variable array of B6 through uh, D7. Okay. Assign a non-negativity constraint. And as far as our consumables, we can use all of this or some of this. We just can't use more than what we have. So as far as our consumables, it's a less than or equal to. And then over here, we have our equality, because whatever we decide to do in terms of make or buy, we've got to meet the order requirements. So that's an equality. And when we go again to solver, we click on solver, and we find out that, okay, so this is our answer cell, E11. Our objective function is to minimize by changing this array of variables, which I already have plugged in. And we have our equality. We have our non-negativity constraint, because we can make 0 or buy 0 model 1s or model 2s or model 3s. We just can't make or buy a negative model 1 or 2 or 3. So that's our non-negativity constraint again. And then our consumables is a less than or equal to. And so once again, if we hit solve, we end up with, and let me slide this out of the way, we end up with the lowest possible cost for the entire order being $453,300. We complete the order. We make all of our Model 1s. We make all of our Model 3s, but we buy 1,450 of the Model 2s and make only 550 of them in-house. And doing so, we use all of our harnessing time and most of our wiring time. And Solver tells us that is the optimum or optimized result. That is the best it can be. So again, this example is a little bit more involved. When you pull down Solver, you'll see I have the, all the boxes plugged in. So from the first example, the spa example, you learned how to fill in the blanks and how to add constraints and so forth. So now your tasking is to do exactly that for this example. Step 1 in your tasking. Make sure you set this up. And again, embedded formulas, look behind there. Anything behind here? Oh yeah. Here? There? Also there. How about here? Something there. Embedded formula there as well, just no embedded formulas here. All right, so be conscious of that. Try and split screen, try and solve this, and you'll have the correct answer there. And then when you're done, try and move the pieces around the board, making sure you adjust the formulas to accomplish that. Again, none of this is hard, it's just tedious. So for those that absolutely hate to do any kind of task work, what some might call homework, well, you're just going to have to swallow hard. It is what it is. So do that. That's part 1. Let me stop share. Now, part 2, I'm only going to introduce Tropicsun, because after you've been able to play with these two, I want you to figure out this third, and I will post the answer later in the week. So in going to this, if we go to the Tropicsun example, here is what is posted, and it's calling it a self-quiz, all right? So this is the storyline. Tropicsun is a grower and distributor of citrus, blah, blah, blah. They have basically 3 groves where they grow stuff, like orange groves, citrus, it's Florida. So they have 3 places where they grow stuff, and they have 3 processing plants. Now, here's the thing. We're trying to minimize what? Minimize costs, and we do that by minimize costs by minimizing, let's call it bushel miles, bushels of citrus. We are trying to get all of this fruit that was grown processed at one of the three facilities. Now, each of these groves can grow so many bushels. Each of these facilities can process so many bushels. They are dissimilar. They are also different distances from each other. And again, the objective is to try and minimize. So I want you to read this stuff. I want you to see what the distances are. And I want you to try now, if you were going to try and do this algebraically, you might try and set it up this way. But I want you first to define the objective function, define the constraints, and then implement the model, right? That is your tasking for Tropicsun. This will be a little bit robust for you and you'll play with it. But this is what I would like you to do the early part of this week. By the end of the week, I'll post a result and the outcome, and then you'll compare what you've done to what this is. And then you will see that this, except for the names and a few other changes, to borrow a line from a song, is almost exactly what the third part of Betty's Bats is. Because Betty's Bats, well, we're not growing anything, but we have three manufacturing facilities. And over here, we have three processing plants, but in Betty's Bats, we're not processing citrus, but we are inventorying and warehousing. And so 3 by 3, different distances, different capacities, but it is identical to, they're pretty synonymous. What is happening at Betty's Bats and what is happening at Tropicsun. If you can do Tropicsun, you can do part 3 of Betty's Bats. All right, let me stop share with that. That is your tasking for the early part of this week. I will post some other things, and then I'm going to start to go through the discussion board because by now we should have posted pretty much everything that we're going to post. So I'm just going to keep it short for you. That's what's up. Email me if there are any crises. I'm going to look into emails. As I mentioned earlier, had a little adventure this week, so I'm back, and I'll take a look at your emails and try and respond as best I can. So we'll chat soon. Enjoy the rest of your day.